So welcome to the last video of the series of the 2017 Live-Solve. It's been a fun time. Took a break for dinner. Now I'm back. It'll be great. Now we have Markov chains. What more could I want? As always, just like try the problem out on your own before you come and watch this video, because I personally find it a lot more useful to like get emotionally attached to problems before I look at the solutions, just because, I feel like I can always pick through the solutions if I try really, really hard, but it's sometimes a lot more meaningful when I myself like found what was the hard part and then was able to discover where I went wrong when I look at the solutions. So here's the classic last problem Markov chain question. Yeah, I have really beautiful work for this on my own final, so that'll be exciting. Yeah, okay, so let's get started. So the stationary distribution of a Markov chain, the Markov chain is x naught, x1, x2, dot, 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 on the state space 0, 1, dot, 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 110, with transition probabilities given by this stuff. So these are all the transition probabilities. Where P and R are constants with 0 less than P less than 110 and 0 less than R less than 1. So I usually start off by like drawing like a transition matrix just to help visualize what this looks like. So we have going from 0. So this is going to be 0, 1, dot, 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 110. And this is 0, 1, dot, 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 110. And going from 0 to any j for j that's not equal to 0. So that's just going to be P. So we have P. I'll add like 2 here. P dot, 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 P. And then this one is going to be 1 minus 110 P. And that makes sense because the row has to sum to 1 anyway. So we have that first normalization just to sum to 1. And then for anything else that's not 0, we have just going to itself. It's going to be, so along the diagonal, it's going to be 1 minus R, 1 minus R, dot, dot, dot. So I guess this is supposed to be in, that's supposed to be on the 2 by 2 element, like 2, 2. Dot, 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 all along the diagonal is 1 minus R. And then we can also go back to the 0. So it's R, R, dot, 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 R. And everything else is 0. All of these sum to 1. Okay, so I'll just like do little arrows for prettiness. Okay, so that's like unclear how useful that is, but at least we know what it looks like, and I always like having the transition matrix around anyways. So one of the ways we know how to find the stationary distribution is using reversibility. Other things we know is like, in the case of the undirected graph, you can use the degrees of the undirected graph. We know birth-death chains are pretty easy to find the stationary distribution. But in this case, we want to use reversibility. So reversibility, like a reversible Markov chain, satisfies detailed balance, which is for all ij. We have S, like a vector S, such that Si times Qij equals Sj Qji. So that if you like look at that, that's like probability you start at I and then you move to J, probability you start at J, you move to I. That's kind of why it's called reversible. There's some like fun, exciting like visuals you can do with that. And if we can find like a vector S for which this is satisfied, then it's called reversible. And moreover, this S is going to be called the stationary distribution. Note that when like I equals J, that like it's just like kind of trivially true. Like this is always true for any like SI. So we're going to focus on when I is not equal to J. So just like looking at this transition matrix, there's not too much like it's a pretty sparse matrix. So for example, we have, let's just start listing things. So S0 going from Q0. So like S0, and then let's start from Q0, which is the first row. We're just going to look at this row. Q0 to J, where J is not equal to 0. So like it's just going to be 1 through 110. So J not equal to 0 equal Sj with Qj0. So what this one is going to be 0 to J. We look at here, it's just going to be P. So we have S0 times P equals Sj times J0. So that's going to be one of these, and note J is not 0. So that's going to equal R. So in this case, we have Sj, so not equal sign, like maybe this implies that Sj is equal to S0PR. So that's pretty useful. And I think that just holds for everything. And that holds for all J not equal to R. So now we have that, and like nothing broke along the way, so things seem to be okay. So we just have S is going to be proportional to S0, comma, and then now for all the J's not equal to R, S0P over R, S0P R, just dot, 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 S0PR. And the number of these, there's 110 of these. And we need to make sure we normalize our stationary distribution. Stationary distribution sums to 1 because they're all probabilities. So we're going to take the sum of this. This is S0 plus 110 S0PR. And we're going to divide every element by this sum. So S itself is going to equal, so no everything has an S0 in it, so we can just get rid of S0. So it's going to be 1 over 1 plus 110 P over R, comma, and the rest of them are going to be P over R over 1 plus 110 P over R, dot, 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 comma, P over R, 1 plus 110 P over R. And I think you can definitely make that a little nicer. So let's just like, let's multiply everything by R. Yeah. Then we have this is equal to R, like the top and bottom of every fraction, plus 110 P, comma, P over R plus 110 P, dot, 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 P R plus 110 P. And just as a sanity check, like let's just sum it up. We have 110 times P on the top, and then plus R, and then on the bottom R plus 110 P. So this indeed sums to 1. So this is our stationary distribution. So yay, that's pretty fun. And that's it for this problem, and that's it for this final. Thanks for coming on the journey with me. I wish you guys all the best of luck studying. I'm really grateful that you guys appreciate these videos. At least you guys appreciated the midterm videos. I got a lot of requests to do the final videos, and yeah, that was nice to hear because it's just me speaking to my computer, doing my own exam problems. I don't think I thought I would be doing this back in when I was taking this class. I'll be having like office hours every other day for 3 times leading up to the final. And depending on how much work I decide to give myself, like I might have more office hours. Feel free to always like email me, Slack message me, if you guys have questions about the finals. And yeah, good luck. Prepare yourself, stay calm, don't stress out too hard. It'll be fine. Probability is great. Hopefully you have a good time and continue your probability journey after this. Yeah, so that's it for this. Goodbye.